Welcome to the third of the videos about trig graphs. So what we're going to do today is we're going to have a look at essentially what happens if we were to put a number in between the cosine or sine function and the x. So what do I mean by that? Let's put an example down. So if we have our basic sine function as y equals sine x, what would happen if I went y equals sine, say, sine 2x, or y equals sine 1/3 x. Okay, and well, we might need to also talk about what happens if we have a negative number in front there as well, but we'll deal with that later. Let's actually have a look at these two examples here. So I'm going to graph all three of these, but let's start with just basically y equals sine x. Okay, so our sine function, because I'm not changing the amplitude, I'll just change the y-axis to say something like -2 to +2 now, so it's a bit easy to see. And let's graph y equals sine 2x. Okay, now what you hopefully can see is that we've had a change not in the amplitude. Amplitude is still the same as the original sine function here, but what we definitely have had a change in is the period of the graph. So let's just discuss that a bit. Okay, so amplitude still 1. Okay, same as the sine function. But what does the period mean? It means, well, how many radians does it take before it repeats itself? Well, if we look at the part which is repeating, okay, so let's try and go over that. Okay, we've got to there, and then it starts to repeat. Well, how many radians was that? Well, pi. So for y equals sine 2x, the period is equal to pi. Now that's half of the original sine graph. Okay, so maybe, just maybe, if I took the original 2 pi radians, which was for the sine graph, and divided it by that 2 there, we might end up with the period of the new function. Well, is that going to be true all the time? No, so is this true every time? I don't mean this answer, but I do mean 2 pi divided by that number there. Is that going to be true every time? Well, let's test it for, say, this one here. Okay, now I think we might need to clear this a bit, but let's do a little bit of prediction first before we clear. So if this is true, if this part here is true, then we might predict the following, that the amplitude of this curve is still going to be 1, but the period, to be careful here, it's going to be 2 pi divided by 1/3. Okay, well that's 2 pi, we're dividing by a fraction, so multiply by the reciprocal, 3 or 3/1 if you really want to prefer that. Okay, and that's going to be, well, 6 pi. Now 6 pi, well, we've only got 2 pi all the way there, so maybe we need to go all the way, you know, and make our x-axis a bit more extended out so we can see that. Oh, well, let's do that. Okay, so I'm going to clear all this stuff out. Remember, we're predicting 6 pi for the period and the amplitude 1 for this function here. So let's clear all that. Let's go back to here. Let's clear all this stuff. Oops, I just put everything on. Hide screen, that's much better. So y equals sine x, and what we want to do now is I want to extend out the x-axis, so left, so I'm going to go negative 8 pi and positive 8 pi, and we'll keep the amplitude, or sorry, y-axis, same as what it was. Now what you're seeing here is simply the sine curve, right? Okay, so this is the period still 2 pi. Okay, let's put in now y equals sine 1 divided by 3x. Okay, and well, what is that blue graph showing? Well, let's highlight a few things. Okay, so from here, here's the repeating pattern all the way, okay, all the way up to here, and still further. Okay, well, we got to there before it now is going to start to repeat. Well, how many radians was that? As predicted, 6 pi. So we've got y equals sine 1/3 x, period is equal to 6 pi. How could I have predicted that? Well, take the period of a normal sine curve and divide it by this number, which is between the sine and the x. So that's going to be 6 pi. And we've seen that the amplitude is equal to 1. Alright. Okay, that's all very good, and I suppose we should have a look at a cosine example as well. So let's clear a little bit of this stuff out the way. Let's put cos x in there. Let's leave our very extended x-axis for now. Let's put in y equals cos, let's put 4x. Well, let's do a little prediction again before we go and graph anything. Okay, y equals cos 4x, period, well, maybe 2 pi, which is the normal period of a cosine graph, divided by 4, this number here, down there, and that's, well, that's a half pi, pi over 2. So we're going to fit a whole cosine function between here and here. So it's going to be something, if I were to try and graph it, let's go down here, all the way down to there, and back up here into there. Well, that's pretty squishy. So it's a very rough, very rough graph. Okay, so that's going to be that. Well, that's pretty tight, but let's see if that's true. Let's get that out of the way, and maybe we need to shorten up our x-axis to make that look a little more presentable in a moment. But we'll just do it off this way first. And what about the amplitude? Oh, I reckon it's going to be 1. Right, let's graph it and check that out. Okay, so let's go back to, and push enter, error in equation. So space there. Here we go. Right, now as predicted, we've got this very squished up cosine graph. Of course, if we extended the r and didn't say extend so much, but actually made that shorter, so negative 2 pi out to positive 2 pi, change that, then that may be a little easy to read. But notice that what we still have, even though we've changed the view a bit, we've still got from 0 to pi over 2, half pi, before the graph is repeating. Okay, right, now what about if we combine this work with the previous video? what happens if we had y equals 2 cos, let's say, 1/2 x? Can we predict what it's going to look like? I hope so. Amplitude. What do you reckon? Remember this number in front here is meant to tell us the amplitude, so I reckon the amplitude is going to be 2. And what about the period of the graph? Well, we've just seen that we can calculate that by taking the normal period of a cosine graph, dividing it by whatever this number is here, which is 1/2. 2 pi divided by 1/2, the same as multiplying by 2, multiplied by the reciprocal, 4 pi. So we're going to go from negative 2 pi all the way out to positive 2 pi for the cosine graph to repeat. Okay, well, let's clear out our existing graphs. And let's clear this out, and let's some of this other garbage as well. Okay, and let's go back now and graph our functions. Right, let's just put cos x back in as a reference. But I'm predicting that we're going to have a cosine graph. It's going to take all the way from here, come down here, hit -1. In fact, it won't hit -1, it's going to hit -2. So it's going to start up here, go down through here, down to there, -2, sorry, down here, and up through pi there, and all the way up to here. Well, let's check that out. So y equals 2 cos 2x, and not 2x, and 5x, or we can put 1 divided by 2x. Okay, and what happened there? Amplitude is 2, but this is not what I was predicting. Okay, so I'm not too sure what has happened here, to be quite honest. So let's see if we can figure it out. Certainly got 4 pi before it repeats itself. And the amplitude is 2. But why are we starting here and not up here? That is what puzzles me at the moment. Okay, so just going to pause the video for a moment. Okay, so just getting back to this again, actually it's entirely what we should be expecting. Okay, I've just put in here y equals cos 1/2 x just as a further reference. Just write that down. And this is this graph here, sort of a slightly pinky one, and as you can see, that is certainly just taken from the same point on the cosine graph, but then you're stretching things out, and it's only because we're stretching things out so much it looks like there's been a reflection, but actually there hasn't. So yeah, we're simply stretching out the graph further this way, and so it appears like there's some sort of reflection going on here, which is not the case. So as we predicted, yes, it's period 4 pi for this one, and yes, the amplitude is 2. And I suppose that might be more easily seen actually from our midpoint out. So here we've got the original cosine graph, this one, and we're stretching the whole thing out like a elastic band all the way out that way 2 pi and back this way 2 pi before it starts repeating. Okay, so there's a little bit of a combination of the last video's work together with this. Okay, I will be doing a video about further transformations, but not until tomorrow at this stage. So I'm just going to pause this now.